Hi everyone, welcome to the Unit 5.2 review video. Let's go ahead and get started. On these first set of problems, we're going to be solving rational equations. And the first step in solving rational equations is to find the least common denominator. Well, in this case, the least common denominator is x. So I'm going to multiply every term in this equation by x. Then I cross out what cancels and multiply what's left. So I end up having 2 plus 3x equals negative x squared. And because I have an x squared term, I'm going to set it equal to 0. So I bring this negative x over to the other side, so it becomes a positive x. Then I want this 3x to come next, so it's in standard form, and then I bring the positive 2. I set it equal to 0, and I factor it. And when I factor it, it becomes x plus 2 times x plus 1. And the reason I chose positive 2 and positive 1 is because they multiply to positive 2 but add to 3. So the solutions are x equals negative 2 and x equals negative 1. Now remember, in these equation problems, it's really important that you double check your answer by going back and plugging into the original equation. So you need to plug in negative 2 wherever you see x in the original equation, and then negative 1 wherever you see x, to make sure there are no extraneous solutions. And when you do that, you realize that negative 2 and negative 1 work out okay. So those are the two answers to problem number 1, x equals negative 2 and x equals negative 1. Well, in problem 2, our least common denominator is x. So I'm going to multiply every term by x. I cross out things that cancel, and I multiply what's left over. So I multiply x times x, and I get x squared. And then I have a minus 12 equals x. Because I have an x squared term, I want to set it equal to 0 in standard form. So I'm going to bring this x over, and I get x squared minus x minus 12 equals 0. Then when I factor that, I end up with x minus 4 times x plus 3. Because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. That tells me that my solutions are x equals positive 4 and x equals negative 3. And I can't stress enough the importance of going back and plugging in these x values into your original equation. And when you do that, you realize that 4 and negative 3 do work, and they are solutions to this equation. Alright, moving on to number 3. Our least common denominator here is going to be 2 times x minus 7. And the reason it's 2 times x minus 7 is because we have a denominator of 2 and a denominator of x times 7, and their least common multiple is 2 times x minus 7. So once again, I'm going to multiply everything by 2 times x minus 7. I cross out what cancels. The 2's cancel in the middle term, and the x minus 7's cancel out on the rest. And I'm left with 2 times 2x minus 9 plus x times x minus 7 equals 5 times 2, which is 10. Then I'm going to distribute to get rid of my parentheses. So 2 times 2x is 4x. 2 times negative 9 is negative 18. Plus x squared minus 7x equals 10. Now I'm going to go ahead and combine like terms. And when I do that, I end up with x squared minus 3x. Then I have a negative 18. And when I subtract 10 to set it equal to 0, it becomes a negative 28. Then I go ahead and factor that. Two numbers that multiply to negative 7 but add to negative 3, multiply to negative 28 but add to negative 3 are negative 7 and positive 4. So this factors out to x minus 7 times x minus 4, or x plus 4. So my solutions are positive 7 and negative 4. Now when you go back in with your calculator and plug 7 in wherever you see x, you notice that when you plug 7 into the denominator, it's going to give you a denominator of 0. And you can't have any denominator of 0 because you are not allowed to divide by 0. So x equals negative 4 is the only solution. because x minus 7 is what we call an extraneous solution. Okay, moving on to number 4. Well, the only denominator we have here is x minus 2. So I multiply both sides by x minus 2, and it should clear out my denominators, which it does. And I'm left with x equals 6 minus 2x. Then I'm going to get all my x's on one side, so I add 2x to both sides, and I'm left with 3x equals 6. Then I can divide both sides by 3, and I'm left with x equals 2. Now, when you plug 2 back into this original equation, once again, you'll get a 0 in the denominator, and you can't have a 0 in the denominator because you can't divide by 0. Therefore, 2 is an extraneous solution. And problem number 4 has no solutions at all. Okay, moving on to problem number 5. Our least common denominator here, we have to first of all look at this x squared minus 1, and you should recognize it as a difference of perfect squares, which factors into an x plus 1 times x minus 1. And if you notice, the left side of the equation contains both of those terms. So my least common denominator is x minus 1 times x plus 1. Now I'm going to go ahead and multiply every term by x plus 1 times x minus 1. And when I do that, I'm going to cross out what cancels. So the x minus 1's cancel in that first term, the x plus 1's cancel on that. And remember, x squared minus 1 is equivalent to x plus 1 times x minus 1, so those all cancel. So my first term, I'm left with 7 times x plus 1. The second term, I have 3 times x minus 1 equals x. I'm going to go ahead and distribute, and I'm left with 7x plus 7 plus 3x minus 3 equals x. Combine like terms, and you're left with 10x plus 4 equals x. Then I'm going to get all my x's on one side, so I'm going to subtract 10x from both sides. And you get 4 equals negative 9x. Well, then I divide by negative 9, and x equals negative 4 divided by 9. And when you plug that into your original equation, you realize that it does actually work, and it is a solution. So number 5 has an answer of negative 4 over 9. Number 6, our least common denominator. When we look across the bottom, we have 5 times x plus 1 as our least common denominator. So I'm going to multiply everything by 5 times x plus 1. I cross out what cancels, and it should clear out my denominators, and I'm left with 5 times x plus 4 plus x times x plus 1 equals 5 times 2x plus 5. I distribute my 5 to get rid of the parentheses, and that's 5x plus 20. Distribute the x, and you get x squared plus x. Distribute the 5 here, and you get 10x plus 25. Now I'm going to go ahead and combine like terms and get all of my variables on one side, so you end up with x squared plus 6x plus 20 on the left-hand side, and there's nothing to combine on the right-hand side. So I bring over the 10x, and you end up with x squared minus 4x plus 20 equals 25. Now I'm going to bring over the 25, and you get x squared minus 4x minus 5 equals 0. Now that factors out to x plus 5 times x minus 1, because once again we looked for two numbers that multiply to the last term but add up to the middle. And that tells me my solutions are it should be x minus 5 and x plus 1. So my solutions are x equals positive 5 and x equals negative 1. When you plug these back in, you realize that x equals negative 1 is not a solution, and it is an extraneous solution. So the only answer for number 6 is 5. X equals 5 does work out. Okay, let's move on to problem number 7. Our least common denominator is x times x minus 3. So I multiply everything by x times x minus 3. I cross out what cancels, and I multiply what's left over. So x times 3x is 3x squared. And then I have 2x times x minus 3. So I get 2x squared minus 6x. Then I'm going to subtract the 2x squared from both sides. And I end up with x squared equals negative 6x. Now, remember, if there's an x squared, I still want to set it equal to 0. So I'm going to add 6x to both sides. And when I do that, I end up with x squared plus 6x equals 0. Now I'm going to pull out the GCF. They both have x's in here, so I pull out an x, and I'm left with x times x plus 6 equals 0. So my solutions end up being x equals 0 and x equals negative 6. So when I plug those solutions back into my equation, x equals 0 does not work because it'll give you a 0 in the denominator and you can't divide by 0. So x equals negative 6 is my answer to number 7. On number 8, the least common denominator is 3x. I multiply everything by 3x. I cross out what cancels. Oh, not the whole thing there. Just the 3's in that first term. And multiply what's left. So I have a 5 times an x. I have a 6 times a 3, which is a plus 18. And then 8 is the only thing that's left on the right-hand side. Sorry, negative 8. So when I subtract 18 from both sides, I'm left with 5x equals negative 26. Then I divide both sides by 5, and x equals negative 26 divided by 5, which cannot be reduced. So that is my answer. And if you check in your calculator, it does work out, and we do not have any extraneous solutions. Okay, moving on to problem number 9. Our least common denominator here is going to be 6x. So you multiply everything by 6x. The 6's cancel, so you're left with x times x plus 5. On the right-hand side, the x's cancel, so you have 6 times x plus 1. Then you distribute, and you get x squared plus 5x equals 6x plus 6. I'm going to subtract 6x from both sides, and you're left with x squared minus x equals 6. Because there's an x squared term, I'm going to bring that 6 over to the other side. And when you factor this, it factors into x minus 3 times x plus 2 equals 0. So we get the answers of x equals 3 and x equals negative 2. And remember, always, always, always go plug those back into your equation. And in this case, they both do work. So x equals 3 and x equals negative 2 are my answer to number 9. All right, in number 10, the least common denominator, once again, we have a difference of perfect squares. We have x squared minus 4, which is x plus 2 times x minus 2. So we know our least common denominator is x plus 2 times x minus 2. So I'm going to multiply everything by my least common denominator. I cross out what cancels. And remember, x plus 2 times x minus 2 is equivalent to the x squared minus 4, so they cancel. And you're left with 4 equals x plus 2 times x. Oh, what's the only thing left on this side is x plus 2. So now we just subtract 2 from both sides, and you get 2 is equal to x, or x equals 2, and you realize that that is an extraneous solution because that'll give you a 0 in the denominator. So problem number 10 has no solution. Okay, now we are done with all of our equation problems, and we need to move on to our inequality problems. And when solving a rational inequality, you have to set up a little table. And if we were to solve this, if there was not an inequality sign on this problem, we would be multiplying both sides by the LCD, which is x plus 5. Now, you have to be careful when you're multiplying and dividing both sides of an inequality, because if you're multiplying or dividing by a negative number, then the sign changes. So that's why we need to set up these 2 columns, because we are going to look at the case in when you're multiplying by a positive LCD and multiplying by a negative LCD, since we are not sure if x plus 5 is positive or negative. So we're going to look at both cases. So if x plus 5 is positive, that means it's greater, oh sorry, not x plus 5, it should be x minus 5. If x minus 5 is positive, then that means x must be greater than 5. And that's the first piece of information we're interested in. Now, x must be greater than 5, and when we solve, we realize that the x minus 5s would cancel, and you'd be left with 3. And then the sign will remain the same because we multiplied by a positive number and not a negative. So 3 will be less than or equal to 4 times x minus 5. Then we go ahead and distribute the 4. I add 20 to both sides. I'm left with 23 is less than or equal to 4x. Divide both sides by 4. And you end up seeing that x is greater than or equal to 5.75. And that is the second bit of information that we're interested in. And then we're going to go ahead and draw a number line with our values of 5 and 5.75 on there. And if you notice, we need to draw or shade the highlighted portions that I have. This x is greater than 5 and x is greater than 5.75. So there's x is greater than 5, and then x being greater than 5.75 is right there. And I highlight the cases that where both arrows are. And if you notice, this is when x is greater than or equal to 5.75 when this inequality is true, and when the LCD is positive. So now let's look at when the LCD is negative. So that means that x minus 5 is less than 0, which means x is less than 5. That's the first bit of information on this side. And when we solve, remember, when we're multiplying by x minus 5 on both sides, this time it is negative. So the sign changes. So we're left with 3 on the left-hand side. The sign flips to be greater than or equal to, and then we have 4 minus x times 5. 4 times x minus 5. So 3 is greater than 4x minus 20. Add 20 to both sides, and you're left with 23 is greater than or equal to 4x. Divide by 4. And you get x is less than or equal to 5.75. You draw your number line with 5 and 5.75 on it. And then we need to shade our highlighted portions. And when we do that, we realize that x must be less than 5 and x must be less than or equal to 5.75. And when we look at where that's shaded, we can write it as x must be less than 5 because the whole area is less than 5, the highlighted area. So our OR statements should always start, so we have this x must be greater than or equal to 5.75 or x must be less than 5. Well, a good OR statement always starts with the lower number. So we're going to start with x must be less than 5 or x must be greater than or equal to 5.75. And that is our answer to the inequality in number 11. Okay, so now let's try another inequality. In this case, our LCD in this inequality is x. So let's look at the cases where it's positive and negative. Well, x is positive when x is greater than 0. And like I said, we would multiply both sides by that LCD. The x's would cancel on the left-hand side, so you'd be left with x plus 2. Now the x is positive, the sign will not change because you're multiplying by a positive number on both sides. And then on the right-hand side, you're left with negative 6x. Now I would subtract x on both sides, and you're left with 2 is greater than negative 7x. When you divide both sides by negative 7, you have to remember that when you're dividing both sides by a negative number, the sign changes. So you end up with negative 2 over 7 is less than x. Or in other words, x is greater than negative 2 over 7. Now that's the second piece, and the first piece was x must be greater than 0. Okay, let's draw our little number line. And we need negative 2 over 7 and 0. And now I'm going to shade what inequalities. It said x must be greater than 0 and x must be greater than negative 2.7. And I highlight or shade where they both are. And I realize that it's telling me that x must be greater than 0 on this side. Okay, now let's look at the or part, the negative side. If LCD is negative, well, if it's negative, then we know that x must be less than 0. And when we solve, we end up with x plus 2 on the left-hand side because the x's cancel. But remember, we're multiplying by a negative number this time, so our sign's going to change. And we get negative 6x on this side. I'm going to subtract x from both sides, and I end up with 2 is less than negative 7x. Divide by negative 7, and when you divide by a negative number, your sign changes. So you get negative 2 over 7 is greater than x, or in other words, x is less than negative 2 over 7. Draw your number line with 0 and negative 2. Oh, I flipped them. With 0 and negative 2 over 7. Oh, I did it again. And then we need to shade what we had highlighted, this piece of information, and x must be less than 0. And if x must be less than 0 and x must be less than negative 2.7, then we know that x must be less than negative 2 over 7. So, on this side, we write x must be less than negative 2 over 7. And remember, a good OR statement starts with a smaller number. So x must be less than negative 2 over 7, or x must be greater than 0. And that is the answer to number 12. Okay, moving on to number 13. We have another inequality. And remember, that's when we figure out what our LCD is, which is x plus 3 in this case. We put a positive and a negative. So if our LCD is positive, x plus 3 is greater than 0, or x is greater than negative 3. And that's the first piece of information. Now we write and. When we would multiply both sides by x plus 3, x plus 3 would cancel on the left-hand side, so you'd be left with 7. X plus 3 is positive, so the sign is going to stay the same, and you end up with negative 5 times x plus 3. Now we distribute the negative 5. You add 15 to both sides, and you end up with 22 is less than negative 5x. Then you have to divide by negative 5. And remember, when you divide by a negative number, the sign changes. So it becomes 22 divided by negative 5 is greater than x, or x is less than negative 22 over 5. And that is the second bit of information that we want. And then we draw our number line. And we put negative 22.5, which is equivalent to about 4.4. Negative 4.4, sorry. And 3. So now I have to shade. The first thing is that x must be greater than negative 3. So if x must be greater than negative 3, I'm going to shade in that direction. But x must be less than negative 4.4. So I shade in that direction, which means there is no solution on this side. Okay, now let's look at the negative side. Now, before I look at the negative side, let's look up at the last two problems we did. If you looked at the highlighted areas, you notice we have an x is greater than 5 here and an x is less than 5 here. Well, all that happened was the sign changed. Well, look at the same thing on the bottom in the second bit of information. X was greater than or equal to 5.75, and here it was x is less than or equal to 5.75. And the same thing happens in the other problem we did. We had x is greater than 0, and then x is less than 0. And then we had x is greater than negative 2 over 7, and x is less than negative 2 over 7. So back to problem 13, all I need to do, I don't even need to do all the work again. I can just flip my signs. So on the positive side, if the LCD was positive, x had to be greater than negative 3. Well, if the LCD is negative, x must be less than negative 3. Okay, and then the way we can write the inequality second part is x must be greater than negative 4.4. Because on the positive side, x had to be less than 4.4. And remember, both of those things have to be true. X has to be less than negative 3, and x has to be greater than negative 4.4. So we draw a number line, and we put negative 4.4 and negative 3. And then we shade. X must be less than negative 3, and x must be greater than negative 4. And where both of those things are both true is in between. So the solution to this side is negative 4.4 must be less than x, which must be less than negative 3. And if it's no solution or this, we are going to always pick the inequality as our answer. So our answer to the inequality in problem 13 is negative 4 must be less than x, which must be less than negative 3. Okay, so let's do our last inequality problem. The LCD here is x minus 2. We put a positive and negative case, depending on whether our LCD is positive or negative. So we want to look at if x minus 2 is greater than 0, then x must be greater than 2. And we know that if we multiply both sides to solve by x minus 2, we end up with 6 is greater than or equal to, the sign didn't change because we multiplied by a positive number, is greater than or equal to negative 4x plus 8. Okay, when I subtract 8 from both sides, I end up getting negative 2 is greater than or equal to negative 4x. When I divide by negative 4, I end up getting positive 1/2 is greater than or equal to x. Or x is less than or equal to 1/2. Remember, I'm interested in that piece of information and that piece of information right there. So I draw my number line. And I put a 1/2 and I put a 2. And then I shade. So if x is greater than 2, it needs to be shaded that way. But if x is less than or equal to negative 1/2, it's shaded the opposite way. Well, there's no point at which both of those things are true. When x is greater than 2 and x is less than or equal to 1/2. So this side has no solution. Okay, now looking at the negative case, remember all we have to do is flip our signs. We don't have to do all the work again. So I'm going to write x is less than 2 and x is greater than or equal to 1/2. I draw my number line. I put a 1/2 and I put a 2. And then I need to shade. So x must be greater or less than 2, sorry. And x must be greater than or equal to negative 1/2. And where both of those things are true is in between those two values. So my answer in this case is 1/2 must be less than or equal to x, which must be less than 2. And that is the answer to my inequality. Okay, so those are the inequality problems. Those are probably the hardest problems on our test. Now let's move to the last 3 word problems. And these are the distance, rate, and time, and the work, rate, and time problems. And problem 11 reads, a biker rides 7 miles per hour faster than a walker walks. So if the biker rode 19 miles in the same amount of time it took the walker to walk 3 miles, what was the rate of each to the nearest tenth? Well, here's the key. It says same amount of time. And we know that they're traveling, so we know it's a distance, rate, and time problem. Well, remember, if it's same amount of time, we always put a distance over rate equal to a distance over a rate. Well, they tell us the biker rides 19 miles, so that's going to be my first distance. And not only that, they also tell us the biker rides 7 miles per hour faster than the walker. So if we know the walker's rate, we can add 7 to it, and that's the biker's rate. And so we're setting that equal to the walker's distance, which was 3 miles, and we are looking for the walker rate, which is x. So the equation that we're going to use is 19 over x plus 7 equals 3 over x. Well, in this case, we can just cross multiply to solve for x. 19 times x is 19x, and then 3 times x plus 7. So 19x equals 3x plus 21. Subtract 3x from both sides, and you end up with 16x equals 21. Divide both sides by 16, and you get x equals about 3.5. And remember, x is our walker's rate. So the walker walks about 3.5 miles per hour. Now the biker, remember, is 7 miles per hour faster, at a faster rate than the walker. So the biker speed is about 10.5 miles per hour. Alright, let's move on to number 12. It says, a kayaker spends an afternoon paddling on a river. She travels 3 miles upstream and 3 miles downstream in a total of 4 miles per hour. In still water, the kayaker can travel at an average speed of 2 miles per hour, and they want the average speed of the river's current. So the key here is they give us a total time. We know they're traveling and that they give us a total time. Well, when they give us a total time and it's a distance, rate, and time problem, we always put a distance over rate plus distance over rate equals the total time. So in this case, we're talking about traveling 3 miles upstream and 3 miles downstream, taking 4 miles. So we know we have a distance 3 miles upstream and a distance 3 miles down, and we know it's the total takes a total of 4 hours. Now the rates are what we need to think about. It says in still water, the kayaker can travel at an average speed of 2 miles per hour. So I'm going to put a 2 below each. But the difference now, if they're going upstream, that's going to slow her rate down because she's swimming against the water. So, and remember, the whole thing is we're looking for the average speed of the river's current. So we're going to make that X. So she's going upstream, traveling at 2 miles per hour. The current is going to slow her down at its average speed. So we're going to subtract that from her rate. And going upstream, we're going to subtract that from her rate. And going upstream, the current will help her go faster. So we're going to add X. Okay, so now we can go ahead and take this equation, 3 over 2 minus X plus 3 over 2 plus X equals 4, and solve for the river's current. So our LCD here is 2 minus X times 2 plus X. And if I multiply everything in my equation by that, then I cancel out what does and multiply what's left. So I'm left with 3 times 2 plus X plus 3 times 2 minus X equals 4 times 4 minus X squared. Distribute and you get 6 plus 3X plus 6 minus 3X equals 16 minus 4X squared. Combine like terms and you get 12. Those 3x's cancel out, equals 16 minus 4x squared. I can subtract 16 from both sides, and I end up with negative 4 equals negative 4x squared. When I divide by negative 4 on both sides, I end up with x squared equals positive 1. Remember, when you take the square root of both sides, you get a plus and a minus. So x equals 1 and x equals negative 1. Well, if x is the average speed of the river's current, it cannot be negative. You cannot have a negative speed. So we know that the solution to this problem is that the river's current has an average speed of 1 mile per hour. Okay, last problem. It talks about a candy factory, and that their machine 1 can produce a case of bags of jelly beans in 5 minutes. Machine 2 can produce a case of bags of jelly beans in 4 minutes, and a machine 3 can produce a case of bags of jelly beans in 7 minutes. If all 3 machines are running, how long will it take them together to produce a case of bags of jelly beans to the nearest tenth? Well, remember, in these job problems, we always put 1 over an individual's time, so we'll consider machine 1 an individual. So 1 over 5 times the total time it would take them, which we are looking for. That's what they want. They want the time together. So we're going to call that X plus, okay, the next individual is machine 2, 1 over its time of 4 minutes times the total time, plus 1 over machines 3 time, which is 7, times the total time, equals 1. Because remember, they're completing one job. So now that is our equation. 1 over 5 times x plus 1 over 4 times x plus 1 over 7 times x equals 1. So now I need to get rid of my denominators, and the way we do that is we find the LCD, and the LCD between 5, 4, and 7 is 140. So I'm going to multiply every term by 140. And when I do that, this reduces down, 140 over 5 reduces down to 28x. 140 over 4 reduces down to 35 times x. And then 140 divided by 7 reduces down to 20x. And then 1 times 140 is, of course, 140. When I combine like terms, 28x plus 35x plus 20x is 83x equals 140. Divide both sides by 83. In x, the total time it would take all the machines working together to produce a case of jelly bean bags would be 1.7, and we're talking about minutes. So if all machines were working, it'd take about 1.7 minutes to produce a case of jelly bean bags. Okay, y'all, I hope this was helpful. I hope that you study really hard and come in and ask any last minute questions in the morning. We'll see you then. Good luck, y'all.